we talked about yesterday. You have this written down already. Okay? If our parabola opens vertically, this is our standard form where the x is being squared, the y is the linear term. Okay, our vertex is always HK, our directrix and focus are always P away from the vertex along the axis of symmetry. Okay? What we are going to do today is we are going to be given pieces of information about the graph, and we're going to have to get back to standard form. So if you look at our equations for standard form, what must we know to write it? Okay, so we need to know what H and K are. And what? And we need to know the p-value. Okay? So if we know H, K, and P, we can write our parabola in standard form. Okay? H and K come from the, okay? P, what different ways can we identify P? Okay? How far is the focus from the vertex? How far is the directrix from the vertex? Okay? So, we have 4 examples. That's it. Here we go. Write down what you need to. Find the standard equation of the parabola with the vertex at the origin and the focus is 2, 0. This is talking about a graph, so what should you do?
Graph it.
You should probably draw a picture. Alright? So our vertex is at the origin. And our focus is at 2, 0. So, first of all, what way is this parabola opening? It has to be opening right so the focus is inside. Since our vertex is at the origin, what is H? What is K? And how far away is our focus? So P is 2. Alright? This is opening horizontally, so the y is being squared. So we have y minus k squared equals 4 times p times the quantity x minus 8. You're not going to say it like that, are you? Let's make it look pretty. Y squared equals
8x. Yeah.
Question? Step it up. Well, is it too much different, is it? Okay. We have a vertex at 2, 3 and a focus at 2, 1. I want to see a picture when you do these problems for me in your homework, on a quiz, on the test. Okay? So our vertex is at 2, 3. And our focus is at 2, 1. What way is this opening? Down. Okay. So if our vertex is at 2, 3, what is H? What is K? How far away is our focus from the vertex? 2, but since it is opening down, it needs to be a negative 2. Right? Okay? So since it's opening vertically, we have x minus 8 squared equals 4p times y minus k. Remember, the 4p goes with the linear term. H is 2. P is negative 2, so that makes it. And k is 3. No, standard form. Next example. Now we're working with the vertex and directrix. So our vertex is negative 2, 1. And our directrix is x equals 1. What way is this opening?
Left.
Okay, it has to open away from the directrix. So we know it's opening left. Alright? So h is negative 2, k is 1. How far away is the directrix from the vertex? 3 units, but it's opening left, so p needs to be negative 3. So since this is opening horizontally, we know our standard form is x or y is being squared.
Y.
So y minus k squared equals 4p times x minus h. So we have y minus 1 squared equals 4 times p would give us negative 12. X minus negative 2 gives us x plus 2. All I really care about is the standard form, okay? I'm flexible with that. Okay, Katie just asked me if she labeled this as P is 3, but then looked at her graph and made the 12 negative, would that be okay? Yes, it would. Okay? Because in our mind, we're thinking of P as a distance, and we're looking at the negative to see which way it opens. So if you label this as 3, but make it negative in your standard form, I'm okay with that. Okay? Now, what would happen, let's say I gave you a vertex of a focus of 1, 1, and a directrix of y equals the negative 3. How would you find the vertex? It would split the difference. So here would be your vertex. Okay. So let's continue with this example that I just made up. Which way is this opening? Up. Our vertex is where? Okay, it's at negative 1, 1.
1, negative 1.
Sorry, I heard you backwards. And what is our p-value? Equals 2. So, rattle off my standard form. X
Squared equals negative 4. Oh, wait, negative 8. Y minus plus 1.
Okay. X minus h squared, 4p 4p y minus k. Okay? Now, when you are given the vertex and either the focus or directrix, things are pretty straightforward, like we've seen. This throws a little bit more work at you, but still, you don't have anything too hard about it.
Right. Yeah, well,
I think it's what. Okay, so I want the standard equation of the parabola with the vertex. 3, -3. And we have a point at 0, 0. Hold on. That's not necessarily the point I'm giving you. Okay? First of all, what don't we know about this? We don't know which way it opens. What ways could it open? It could open left, it could open up. So first of all, I have not given you enough information. Okay? So I'm going to add that it opens up. No, I wanted you to see you can recommend that. Okay? So this is opening up. Okay? We know nothing about P. That's really too bad. Okay? But we know what H and K are, correct?
Yeah.
So we can at least write, okay, this is opening up, so the x is being squared. We have x minus h squared equals 4p times y minus k. What do you say? We have a point on our graph. We have an x and y, and we know that any points on our parabola should satisfy our equation. So what we can do, per Davis' suggestion, is plug in our point so we can solve for p. Alright, so on our left side, 0 minus 3 the quantity squared. 4p times 0 plus 3.
12p.
So what's p?
3/4.
So our standard form is x minus 3 squared equals, what is 4 times p?
3. That's awesome. Lovely. It's 9 by 12.
Yeah, let's divide this over. Okay. This will be the most difficult of examples because it requires the most work.
That's the most work. I can live with that.
For these types of problems in this section.
So, for the whole year.
That's all we're doing today.
This is the most work we're doing.
Where's the what?
We need to find the root.
Well, in this case, alright, if P is 3/4, where is the focus? It would have to be at 3, 3, -2 1/4, right? And our directrix would be at y equals -3 3/4. Oh.
That right there.
This one?
The directrix.
So,
Oh yeah, it goes in the main.
yeah, so we're talking about the distance from here and the distance here. Those are equidistant. This is the point that we would plot if we were graphing.
Apparently this is
Uh,
right there, incredible. Like, yeah,